All right, it looks like I am good to go. Just anyone let me know if you can't hear me or anything like that, as usual, of course. But my audio levels and everything look good, so I'm expecting this is all right. Now, if you were here, what was that? When did I do that? Wednesday? 2 days ago? Well, it turns out almost exactly the same time. Today is a little bit more of a whim. I started streaming just some hacking around with some I2C devices on my Raspberry Pi 2. Raspberry Pi 2, I am running a full Linux distribution, and sorry about that. I am SSH'd into the device itself, and I know that lots of people have comments like, oh, well, you could just do this on, Visual Studio Code and connect to it remotely or something like that. And you know what? I just think it's kind of fun to actually develop on the Pi itself. And at some point, maybe I'll move this over to my Pi 4, or I'll get another Pi 4, and then we'll really see just how fast a modern Pi actually is. But it looks like, it looks like the date is completely off on this Pi. I should probably fix that at some point. But for a quick review, we've got our MPU. What is this? We have a list of all of these things in the source code, which is available in this I2C hacking. If you look at the video description, I've got a link to the GitHub, and I've got a link to all of the things that we're working with here. But I've got this file here. I've got a motion sensor, position sensor, multi-axis thing at MPU 9250. Have not started talking to it yet. I have a 128 by 32 driven by an SSD 1306 from Adafruit device that I have turned on right now. That's where we are, is we have this turned on. We proved that we can talk to it. Most of the time was spent talking to the RTC here, which this device has a real-time clock and an EEPROM built into it. And so if we do our I2C detect here, then we can see device 3C is our OLED, device 68 is our real-time clock, device 69 is this multi-position sensor thing. And I've got this wire right here is hardwired to high because this is address line 0. So this is making it 69 instead of 68. If it were 68, we would have a conflict with our real-time clock. And then device 50 is the EEPROM on here. Now, Claim asks, what's the goal of this project? I have no goal for this project. This is just to have some fun and programming or playing around with I2C devices. Although, I should, just a moment, I'm gonna see if I can find something real quick. Really should try to keep your hobby things all in one place. And I am bad at that. I am really bad at that, actually. Still looking. Well, anyhow, I have this really inexpensive fitness watch, that is, that had an OLED display that was almost identical to this one, but a different color, and a real-time clock, and a step counter. And I started to realize at some point that this is probably really, really similar to what the hardware is that was actually in that watch. So at some point, I'm going to do an episode where I tear apart that watch and we're going to look at what's actually in it. and see how much it corresponds to the devices that we have here. So that was part of the inspiration for this. The other inspiration is just that I like messing with hardware. And I haven't had the opportunity to do that at all professionally in the last now 15 years, something like that. So it's just to have some fun. So this code, which I just ran, I ran the I2C hacking project, and that initialized the OLED display, put all of the pixels on, and read the current time out of the RTC. So we can see I powered this system on 24 minutes ago. And if I run it again, we should watch the OLED display flicker. Yep, there we go. Turned it off and back on again. And I have had the device up for 30 minutes and 57 seconds. I see I got a question here. How did I learn, or where did I learn about electronics? And I know very little about electronics. I know mostly what I know is just from the C and C++ perspective of talking to devices. And what happened, and I actually do think that this is a relatively valuable story to share for those of you who are interested yourselves, is I got started at a company that was doing a home automation system. And they needed someone to work on an embedded project that was part of the system. So I was working on the GUI software on an embedded ARM system, but we were still running full Linux. So it wasn't really like we were doing embedded development. And we used Qt for all of the GUI at that point. And this is like 2004-ish timeframe. And they needed someone to volunteer for a project that could talk IR, because we needed to be able to actually send and receive remote control commands to stereos and DVD players and that kind of thing from our home automation system. And so I just volunteered for that. And then in the course of volunteering for that, I ended up with oscilloscopes and multimeters and stuff on my desk, and ended up having to debug the hardware interfaces in cases where, for example, in one of the prototype boards, the RX and TX lines were swapped between the ARM CPU and the PIC microcontroller that I was talking to, and I got the opportunity to learn a bunch of stuff. So I just recommend that if you're interested in learning things, go work for a company that does stuff and then volunteer for everything that you possibly can. That's my recommendation. All right. So what I want to do today, and this was bothering me after we stopped yesterday or on Wednesday, is this kind of very poorly organized code that I have. I've got this code that can open a device, it returns a file handle to it, and I've got just this kind of mixed match of code that I open a device, I can call init on it and whatever, but then actually trying to talk to the device, I'm gonna just try to do a little bit more organization here. So I want to create an I2C device. And I'm not entirely sure what organization I'm going for yet, but I know that I want something just more organized. So I want to create a unique pointer here that will automatically open and close this device when my I2C device goes out of scope. That's my goal. Yeah. As far as I know, well, a good GPIO library for the Raspberry Pi, I have no idea. I am using the Linux I2C facilities that are built into the kernel here because that's the recommended way of doing it on a Raspberry Pi device. And I just have to open the proper device and do the proper things here. So we're just trying to make this all a little bit cleaner. So I want that and that. And as someone said, this screams for RAII. That is what we are going to do, hopefully, here. There we go. So, for between a Pi or a Pico. So it's one of the things that I want to do is try to make this so that everything that we access is through an abstracted I2C device so that it could be minimally modified for other hardware. So I just have some handle that's being handed back to me that's going to be automatically managed, and then everything I'm going to do is going to be through a couple of high-level interface functions, and then hopefully the rest of it would be reusable code. That's my goal. Was it problematic to use standard array for I2C name? Oh, no, so this code, if you weren't here on Wednesday, this code was just copied and pasted from the official examples on kernel.org. Here. So this is one of the links that's in the video description. And so I'm just trying to make it better now. I'm going to get rid of snprintf and all of that. Well, right this second, actually. There we go. That should do it. No, not an int star because, oh, no, wait. That is a unique pointer to int. I just realized I've only ever used unique pointer with file pointer. It's a good point. So if I say that it is holding an int pointer, an int, then it's going to expect me to pass in a pointer to an int. Well, that's kind of annoying now, isn't it? Thought we could use it for this case. But I guess unique pointer really does want pointer-like things now, doesn't it? Let's double check that. Yeah, I'm probably going to go the Destructor route, but I was just thinking, hey, maybe I could avoid that. Yeah, all right. While I type this in, you can discuss amongst yourselves what exactly would happen if I didn't disable all of these assignment operators and copy constructors and such. It's actually a really fun exercise in understanding the implications of our special member functions. I think it's a fun exercise in understanding the implications of our special member functions. Not everyone would agree with me necessarily. All right, I'm gonna make sure those are all deleted. I've got those, and then I've got a couple of aha! Claim just said that you would at least set it for move only. I cannot safely make this move only without actually fully implementing the move destructor, move constructor, and move assignment operator. It's NeoVim. Yeah. So I could do it. I just don't feel like implementing it right now for move operations. This is, I'm going to just go ahead and say this. If you have a reason to implement a destructor like I did here, just go ahead and delete the rest of the special ed member functions until you're ready to properly implement them. It's almost certainly that it's going to take like real work to implement them. The destructor, okay, if you have a destructor that throws an exception, it is extraordinarily difficult to actually deal with destructors that throw exceptions. I would not deal with that. At the moment, I would say I am not using exceptions, but there are certainly cases where exceptions could be thrown, like if I gave a bad format string to format or to speed log. But the rest of this is C API stuff, and so I'm not directly using exceptions myself. And I'm not planning to at the moment. The Linux distro I'm using on the Raspberry Pi is Raspbian. The Linux distro that I'm using on the host that I'm SSHing from is what? Manjaro. All right. So then I want to actually make this real-time clock work. So I know a lot of you are probably going, yay, we're going to get more of the OLED working, but I really actually want to spend some time on the RTC. So I spent the last couple of evenings, just kind of pondering this in the back of my mind. And I'm using structs here because I always prototype my code as structs. It's just easier to deal with. Classes, then I've got public and private and whatever. But if I've got structs, then I can just really easily inherit and blah, 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 whatever. I'm just making everything public for the moment. I might come back and change that. But we've got some RAII action going on, automatically managed thing. And I want to load up this real-time clock. So I'm thinking about using inheritance here. It's not necessarily the route that I would have to go, but I think it makes sense. What is it's a DS 1307. Yeah, actually, it's interesting that there was a discussion on Twitter just yesterday. Yeah, Wednesday. It was Wednesday. It was after my stream on Wednesday. Someone asked Odin Holmes his opinion on whether or not these things should be const or not. And it's a really great question. Odin was discussing whether or not you want to think about it as modifying the state of the device or the state of the class. And so, arguably, the ReadByte, arguably that should be const, I guess. Although a ReadByte could still implicitly change something in the device if it has an auto-incrementing counter of some sort, where each time you read, you get the next byte back. So I don't know. Read, yeah, sure, definitely, maybe const. Write, maybe not const, just depending on where you want to enforce what at what level. The I2C device, what does it do commonly? It opens the handle and sets up the device ID and adapter and then gives you some convenience functions. So it's definitely a common interface to things. Which order did I put these in? I need to make these things strongly typed at some point. All right, so I'm creating it from that known address. And then, let's see, I don't need to... I can start deleting this commented out stuff. I now know what the thing is. And these comments from the official example, I can get rid of those. I'm reading all of your comments. I would normally have video on me on these streams if you haven't watched my streams in the past, but I don't at the moment. I'm gonna... Okay, yeah. Must you give your struct such bad names? The O2C can only understand such types. Huh? Must you give your struct such bad names? How's it a bad name? It is in fact the DS1307 RealTime Clock. If I'm talking to specific hardware, it's pretty nice to know the exact chip that I'm trying to talk to. All right, I see you're having your whole conversation here about whether or not these fields should be const. At some point, come to a conclusion, and then someone make sure you get my attention, and I'll do whatever you all said. So I've got a DS1307 RTC. I seem to have gotten NeoVim angry with me. I'm not sure why. What are you doing, NeoVim? What keycode combination did I just hit? I still don't understand what I should be writing in English. It is the DS1307 RTC that is the chip. It is a DS1307 real-time clock. I could spell out DEESESS 1307, I guess. I'm not sure. Come on. What in the world? It's like scroll lock was hit. But there's no scroll lock on this keyboard. I need to delete that swap file. All right. All right. I would just like to state for the record that I am a huge fan of being as explicit as possible and using really good naming and stuff. But I also would like to say that in a particular domain, there's no reason, in my opinion, no reason to spell out real-time clock, because anyone who is in the hardware domain is going to know that RTC is a real-time clock. So just like you wouldn't explicitly spell out like, oh, okay, just as an example, I have seen code in C++ that is this. You're not going to do that if you have more than 2 months of experience programming in C++. That's my opinion there. And I guess I can have I have fairly strong opinions at times. So none of this is compiling, by the way, because it's trying to call itself recursively with the wrong number of parameters. All right. I would do it if I got paid by lines written. What are you talking about? Send byte's not been declared. What? Oh. Oh. Yeah. That. Oh no. Oh no, there it is. Send byte. Okay. Send byte? ReadByte? What am I doing? ReadByte, write byte, send. Oh, send command. I wonder how I did that. All right. Fix that. Non-static data member declare. Oh, yeah. Template call. Close is not declared in the scope. Is that not? I used open to open it. Do I not use close to close a device open with open? fine. UniSTD? Really? Alright, whatever. Too few arguments to open device. On line 246. I am, to answer the comments here, I am trying to close the thing that was opened here with a regular Unix open. I'm opening the device adapter 1 here, which is Linux provided device. Alright, so I think I got that refactor working. Yeah, alright, that seems to all be good. So I feel slightly better about this. Now I'm going to roll up the SSD 1306 in a minute, but there's something else I wanted to do. Now at the end of Wednesday's discussion, someone said that I should have, that I should write a PMR allocator that talks to the real-time, to the RAM that's on the real-time clock. Okay, so a little bit of context here. The RTC has an extra 56 bytes of RAM that start at address 8. And that's interesting. What do we do with this RAM? I'm not going to create a PMR allocator. I don't think I'm going to make a PMR allocator. Would batching commands that need to be made with RAII to the device a good choice? Maybe. Maybe. That might be a good choice. The problem is if something goes wrong in the Destructor when you send the batch of commands, but I'm not going to go to that point yet. Not using any LSP. I don't know what that means. Right, these devices may or may not be on the same bus, so what I'm doing does seem to be valid. PMR with fancy pointers. Yeah, all right, so this is what I want to do. I want to make this RAM space usable, and I have a plan, and you all can tell me if you think this is a good idea. I'm probably going to get require syntax wrong at some point here because I'm definitely still getting used to it. Oh yeah, no, I don't have a language server. Definitely don't have a language server running on my Raspberry Pi 2 with 1 gig of RAM right now. I'll say that is absolutely not something that I am doing. And since I am doing the development directly on the device, yeah, I don't have that at the moment. I'm just gonna try to even just compile that and make sure the require syntax is even accepted by the version of GCC that, oh no, it's not going to be accepted by the version of GCC I have right now, is it? I'm on GCC 9-F concepts. I don't want to go down that road at the moment. All right. I'm not sure the best way to organize this code. I'm working on it. Yes, the stream will be saved. Can I allocate 56 bytes in one go? Let's see, I'm not sure. Yeah, link step takes a long time. Oh yeah, you might be right on that requires clause. Why not cross compile? Because it's just more fun this way. That's just my opinion. I'm just having fun. And yeah, I think it would be possible to use PMR, but I could be wrong. Going back and looking at your comments and questions here. Yeah, what if I want 1 byte for this, 1 byte for something else? I actually, I think I have a solution for that. So we'll see in just a moment. All right. I'm just gonna put the pointer to const here. Does your GCC version support Bitcast? No, it does not. And Bitcast actually doesn't have me here because I want to read the bytes out of it. And this is actually totally legal, just for the record, because I am allowed to read or write into a trivial object via a pointer to 8-bit thing. Either you can use uint8t or int8t or car or unsigned car or byte. Those are the allowed types. No is POD has actually been removed from the standard. Deprecated from C++ 17. Is trivial is a better option at the moment. And I'm just reading and writing data to this device. If I were to write to this and then try to read to it from a different architecture, I might very well get bytes that are out of order relative to what I expect. I could put like a header on it that indicated what my current Indianness is, which would be interesting, but I don't plan to do that at the moment. So that all should compile to something relatively efficient. Actually, it should completely unroll this entire thing into just like, 10 byte writes or something like that. It should be able to unroll the whole thing. If it chooses to, that'd be up to the compiler. Oops, exited from here. All right, I'm going to write a quick read object back function. So this lets me specify the offset if I want to specify the offset. And I'm going to actually, let's see, no. Yeah. Create a thing in memory, because no one's going to tell me that copying a 556 byte or less object is going to be too expensive. That's for sure. Create the thing. All of this code stays the same, except I want to read the byte at that address. Oopsie. Into here. Same loop otherwise. I think that's right. All right. Yeah, right, exactly. So if I put the coin cell into the thing, then it would persist between reboots. And I think this just has a lot of fun to it. I don't know, what kind of object do we want to write into it? No, I don't know. That did compile, but I am not actually trying to invoke the instantiate the function yet. Yeah, someone wants me to write hello world. I agree. I kind of want to write hello world too. But doing that in a reasonable way is just relatively annoying. Because I need a C array, right? Like if I try to write I need a C++ array. If I try to send a C array, it's just going to copy a pointer, and that's just going to be obnoxious. That's not what I want. That should work. That's going to create a C std array, a standard array from a C array, which in this case would be hello world. So if I write this object at location 0, I might have to run upstairs and get a coin cell for this. No, not is array, to array. It's possible that I don't have that. To array is C++20. I know that. Well, either way, I don't have it in this version of my standard library. All right. There's probably a better way to do this, but when I'm live streaming, I don't necessarily think of all of the options, and I don't see anyone else giving me a better option. So too many initializers for const character of 5. What? 1, 2, 3, 4. Oh. Did someone already comment on this? All right. No, you didn't. Yeah, I think that this is actually going to be pretty liberal in what size cell it can take, because as long as I have the right diameter, the thickness, it looks to me like it can take a couple of different thicknesses, honestly. And I've accidentally learned that those lithium coin cells are shockingly interchangeable when I've put the wrong one into a particular calculator or whatever, and it still worked. No matching function call to read data. Read object. Template argument deduction failed. Unable to deduce. Oh, why? Candidate read object. Because I passed in an extra parameter that I didn't need to. And unable to deduce type because it wasn't able to deduce the function type. All right, that's fine. Yes, so there is that option. I can overwrite assignment to read only location. Oh, because I'm doing a cast to a const character pointer. None of you caught that either. Aren't you all supposed to be helping me here? I thought all of the same diameter coin cells were the same voltage, but different amp hours. Might be wrong on that, but I thought they were all the same because they're effectively one cell. All right, I'm getting all kinds of warnings. That's because ReadByte is expecting an uint 8t, but let's see what happens. Oh. Wah, wah. Huh. All right, let's look at this write object code. And ReadByte. That's my start. Let's make sure that's correct. The start is at 8 hex. If I write the object, I'm taking the data and I'm writing all of the bytes that are in the data. Okay, fine. So I'm just doing a pointer cast to that auto pointer. And then the 8 is my start, my offset. Whoa, 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 whoa. I doubled up on all of my actions here. I need to write from the start plus the offset plus the current index. Yes. The value that I am currently reading, which is, okay, that's better. And in here, I need to do the same change. Read the byte from the start plus the current index plus the offset into RAM. You do not return data. I do not return data. See, you know what? That's also a really good point, right? I just ignored all these, oh yeah, I got a bunch of warnings, whatever, there's warnings here. And then I just screw up even further, right? So let's go ahead and get rid of these other warnings so that we quit making this mistake. I do like being explicit about my static cast. I know some of you don't. You would rather that I did this, which, you know, they're going to accomplish basically the same thing. What's the interface to next? Next can go forward or backward, but it takes what? Pointer diff t, basically. Aha, I still get the narrowing conversion here. Line 235. There is an actual possibility of overflow here, but I do, with static asserts, make sure that that's not going to happen. Same deal. See what your comments are. Use U8T to avoid the cast. I could use int 8t. Which I know that this is all good, again, because of my static asserts. Start plus offset. Oh, wait, right. U8T. Oh, let's forget it. I'm just going to undo that. Yes, probably. Yes, there's probably a better way to have done this. I'm going to get, so I use standard next here actually to specifically answer a question that I'm planning to do a video about soon, because if you use the core guidelines checkers, they tell you to avoid pointer arithmetic. And if you use an index operator like that, then you're going to get a pointer arithmetic warning. And if you use a plus, then you're going to get a pointer arithmetic warning. But if you use standard next, then you don't get a pointer arithmetic warning. So I'm going to use standard next here. And at some point, maybe we'll get back to that and clean that stuff up. Conversion from int to uint8t for the hours field. Time field, hours. Yeah, I hate this integer conversion nonsense. I got back a uint8t and it's being converted, it's being automatically promoted to an integer because I'm doing a bitwise I'm just going to write a function that is 2uint8t or something like that. All right. Yes, if write RAM bytes yes, it would have been easier to write, but harder to read, in my opinion. And you then, the read is the real problem, because I'm guessing whatever you're going to suggest for the read would end up being undefined behavior. And this is not undefined behavior, because I am copying straight into the memory. Hey, there we go. All right, so now we have a nice little user interface. I am totally okay with spending time creating something that lets me read and write objects of a particular type from this thing. And now I feel like this RTC is starting to get somewhere. Now, the next thing that I wanted to do with the RTC, I am a little bit unsure of. But would it not make sense to have this thing actually be able to return the current time from a chrono perspective? What do you think? Should I spend time on that? Or should I move on to trying to get pixels out onto the display? Parses a chrono object from a stream. All right, thumbs up for chrono. Let's see what we can do. Now, I don't know what language doesn't do automatic conversions like this. This is not a C++ problem. This is anything derived from C kind of problem. All right, let's see what I know so little about Chronos. This is really going to be a learning experience, and you all are going to have to tell me what I'm doing wrong. All right, so it's a time point. All right, what does chrono now return? Okay, it returns a time point. So that's what this wants to do, is return a point in time if I read the time. And time point is a duration since epoch. Okay. Does it not have any other? All right, what is the clock? A clock on which this time point is measured. So system clock represents system-wide real-time wall clock. All right, so I guess, oh no, a system clock is unspecified epoch. I need to, All right. I'm looking at the chat messages here, and I don't. And half of the things I'm looking at say since C++20, there is a huge number of changes here. A steady clock represents a monotonic clock. Meets the requirement of a trivial clock. Most suitable for measuring intervals. Is it not possible to just create a time that represents a moment in time with hours, minutes, seconds, days, month, year? I could read it into a time t. Oh, time t is unspecified, so I can't read and write to it. It's almost always this, but that still doesn't help me. I don't want to convert this thing to a number of seconds. Yeah, time t doesn't help me unless I've got a returns the current time, converts the time since the epoch. No. When this shouldn't be this hard. Steady clock, high resolution clock, system clock, time point. A point in time. Constructs a new time point. So if I default construct a time point, can I set hours, minutes, and seconds on it? From the start of the epoch again, okay. Everyone's saying I have to create a new clock. What in the state of the clock registers be an implementation of time point? I have no idea. And just for the record, this has nothing to do with, I wouldn't say this is a convoluted language. It is perhaps a difficult to understand library that's in the C++ standard library. Be an implementation of time point. It seems like time point is literally just a number of clock ticks. Yeah, that's what time point is. It's a number of clock ticks since the epoch. Must meet the requirements of a clock. Okay, right. So, so I can create a clock. And you all are saying I should create a clock. When I have the clock, time point should work automatically. All right, so you're all suggesting that I create my own clock. I still feel like that doesn't gain me anything directly, right? Because I still have to read out the hours, minutes, seconds, day, month, year, and create that and convert that to a number of... I feel like where I am at the moment lost is like actually looking at a time point. I need to look more at time point. Sorry. Because I do legitimately feel lost at the moment. A point in time. Its member functions are time since the start of its clock. That's what it expects to have. I think this is more difficult than it needs to be. Oh, I think I have an idea. I think I do have an idea. Maybe. I'm actually really curious about something now. All right, so my idea, while I'm thinking about this, is they use operator chronosys days. All right, so let's just say theoretically, as I load the hours out of the clock, I convert that to a duration for a number of hours. Then I add the duration for a number of minutes. Then I add the duration for a number of seconds. Then I add the duration for the number of years since whatever, 1970. Then I add the duration for the number of months since January. Then I add the duration for the number of days into that month together. And if I add all of those things together, then I get something that is the combination of all those things. And I keep seeing someone say, just have to implement the clock and everything else will work. But I don't see the information that I need for how to implement a clock. The clock just appears to be the number of seconds since the epoch, which still means I have to calculate all of those things. I don't know, actually. And even if I did that, that's not going to take into account things like leap years, for example. All right, so none of our standard libraries have calendar and time zone implemented here anyhow. So that's my problem, is I can't just take the number of seconds out of this thing and do something meaningful with them because of all of the other problems, leap years and all the calendar calculations. Ooh. Okay. All right. I'm with you here on this one. Aha. Maybe I can use that. All right. That might be a really good option here, because I can just populate all these things and then get a time t object back and just convert that to a system clock To me, that makes an awful lot of sense. That seems like working with this as it is intended to work with without having to implement my own clock. But maybe you all can disagree with me, but to me that makes sense. Let's see, system clock with a from time t. That totally makes sense to me. I'm going to start down that road, and if you disagree, then go ahead and post your grievances in the chat. Wrong way. Just want to verify that that is in fact a 24-hour clock here that's expecting. It is. I'm just going to assume that this thing is actually in that it's in 24-hour clock mode. I've been forgetting to do these kinds of things here. That's definitely a const expr function. Get us some warnings if we try to do anything like that. I start getting magic value warnings here. I do have to actually trim off an extra byte from this if you weren't here for that yesterday. I'm just going to delete those comments. All right, hours, minutes, seconds are loaded, and now we need to get the rest of this thing, which is the current day. Day versus date. What am I looking at? Oh, that's day of the week versus day of the month. Okay. Just copy the ratios from month and year from CVS. Yeah, I could, but that's still not going to take into account leap years and leap seconds and all of the other calculations that need to happen to actually generate the correct number of seconds that have occurred in these number of years and days. That's the problem. That's why I can't just do that. I need to go the other direction. Current time should record a time point. Yes, it's all being recorded and saved on the channel. Yeah, and a DVR function should be enabled. Let me double check all that right now, just in case. DVR, yeah, it'll all be good still. Wait a minute. Interesting. Okay. So time T is expecting weekday from 0 to 6. And I have 1 to 31 in my calendar here. Days since Sunday, years since 1970. All right. What am I doing? I have no idea. All right. I'm going to go this route. So these things are stored in like a form of binary coded decimal, which is why I'm using this helper function time field, which splits it at the 4th bit. Wait, day of week is 3. Day of month is 4. And then year is 5. All right. Oh, but my helper function here for time field is actually splitting off only the top 3 bits. And it's only for the seconds that I actually want to do it that way. So for seconds, let's go ahead and do that ourselves. Okay. All right. modulo for the 0 to 6 translation, couldn't you? And just subtract 1. Seems easier to me. I don't know. All right, so I can read out the seconds, minutes, days, day of week, month, year. Okay. And you're saying that the system clock here should return a time point. All right, I'll get to that in just a minute. I mean, it's literally just the current month minus 1, so... the number of years since 1900. Weekday is day of week minus 1, because that's 0. And I don't have day since January. And this clock doesn't keep in count daylight savings time. All right, I guess that's up to me. And now the question was... from time t returns a time point. Yes, sorry, you are correct. Did I do that right? Yeah, I just thought that it might have a flag that you could save, but I guess that's what I could use my extra RAM for, right? If this is gonna compile or not, I probably need to include time point. Unexpected unqualified ID. What? 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 Oh. 3, 4, 5. Did I miss month? Hello. Register 5. Oh, register 6 is here. All right. Ooh, all right. How long have I been streaming for? When did I start? This has been going 2 hours already? Yes, it is entirely true that I could result in reading a split time. That is just a spectacular point. Let's deal with that in just a moment. I'm just going to remove that. Oh, datasheet page 8. Like we should read the manual or something. All right, let's look at that in just a second. When reading or writing the time and date registers, secondary buffers are used to prevent errors when the internal registers update. When reading the time and date registers, the user buffers are synchronized to the internal registers on any I2C start. The time information is read from the secondary registers while the clock continues to run. This eliminates the need to reread the registers in case the internal registers update during a read. The divider chain is reset whenever the seconds register is written. Write transfers occur on the I2C. Acknowledge. Once the divider chain is reset to avoid rollover issues, the remaining time and date registers must be written within 1 second. So it's synchronized on any I2C start. The fact that I'm actually reading this as 8 different, completely different reads, that is a problem, right? During a multi-byte access, when the address... Okay, so I actually need to do a multi-byte read, not read each of these registers separately to address that problem. Yeah, I agree. All right, let's get this compiling, and then we'll fix that problem. Yeah, that's a really good point. Let's get back to this page. So I've been doing this. What in the world? How is read block data? I can read 2 at a time, but what the heck? This read block data doesn't give a size at all. How much data is it going to read? Right, fine, okay, that gets a length. Why the heck doesn't read have a length? Oh, of course, and there's no docs on that here. All right, so I didn't break anything yet. Let's see if I can print this thing out. I just don't expect that to compile. Big enough to hold the data returned by the slave. SM bus allows at most 32 bytes. Okay. All right, we'll see what happens. Oh, I missed that somewhere someone gave me a tip today. Thank you for that. No, it's still saying it can't format that, even though format lib should allow this. Time since epoch. But it doesn't seem to be allowing it for me. Maybe I forgot to save. Oh, do I have to include? Okay. I forgot that they did that kind of thing. All right, so we need to come up with some sort of way of actually reading all of these bytes at once, which it said is at most, where did that go? At most 32 bytes. Hey, this might actually compile. I wonder what it's going to say, because the current year is actually set as the year 0, I think. So is it going to say Year 0? Is it going to be smart enough to do that? What's it going to print? Current time, negative 1 million billion nanoseconds. That's not actually very helpful. Ugh, alright. Alright. Yeah. What a pain in the rear. You don't think I have to subtract 1700 from the year, or 1900 from the year? I'm pretty sure I do. Because this thing is a... Oh. It's the year 0 to 99. Valid up to 2100. This is the year 2000? But if it keeps track of leap years, then that means it has its own internal idea as to what the base year is, right? It can't just say we can't just assume it's 1900 or 2000 because they would have slightly different leap years in them, right? You said don't think it matters. I thought it, because there's not just leap years. There's leap years, leap centuries. All right, this is going to be quite the little foray here. Aside. All right, dropping February 29th in the 3 years, multiples of 100 that cannot be exactly divided by 400. So 1900 is not a leap year. Neither will be 2100, but the year 2000 was. Let's just assume this thing starts from the year 2000, 00, instead of 1970. So if I'm starting from the year 2000, and this is expecting time since the year 1970. That's still just going to give me probably something relatively meaningless. Yeah, is there... I didn't see a mention of epoch in the... No, I don't see any mention of it. What a pain. Make our own assumptions, I guess. I mean, it's a real-time clock, and it says it's good for 100 years, so I'm going to say it's starting at the year 2000. And sure, maybe that's right-ish. However many negative nanoseconds that is from the year 21. All right. All right, we have to deal with synchronizing this time somehow. Synchronizing the data in this thing from time to time. If it can read up to 32 bytes, from the sake of safety, I just have to assume it's always going to read 32 bytes. Yeah. I have to. Otherwise, the possibility of it overwriting data, overwriting unexpected memory, it just seems far too high. I don't like that at all. That really annoys me. I really wish there was a read command that didn't just say read however much it feels like getting back. And you can see my terribly inconsistent set of whether I'm using trailing return types or not at the moment. I know I'm being inconsistent about that. All right. Do I get back how many bytes I read? Where did that page go? I need to start closing tabs, huh? Byte array into which data will be read, big enough to hold the data, allows up to 32 bytes. Returning negative error no, else the number of bytes in the slave's response. All right. That doesn't really help me, though, does it? I mean, if I'm going to return the small buffer, or I can have the small buffer passed in, Yeah, I could go to a lower level. That's true. I'm going to go down this road at the moment. I need to wrap this up in a second here. I feel like there's better solutions here, but I just want to see if my code is working. In a reasonable way. All right. Since when does int have .data? All right. Second. There. Oh yeah, I definitely do need to wrap this up. Here's hoping this works in a moment. Oh, I don't know. I feel like we kind of are reading into a chrono thing, but I need a better way of printing a chrono thing. It seems a little silly. Looks like C++20 gives us better options for formatting the date, year, month thing. Let's take a look at what other chrono print options there are, because I would just think it would be awesome if this was actually working. To lossless integral, what? Parses a put time like format string and invokes handler actions. Well, maybe I can actually print it as a date calendar thing. Looks like I might be able to. Error reading byte of data from 0. SMBus read block data. It looks like this thing is not actually set up to be able to read data blocks. Gave it the offset, and I gave it a pointer values, and it gave me an error back. Boo. Boo. That doesn't seem to work. In regards to using require set a maximum. Oh, I see that I've got some buffering going on. Sorry about that. I'm gonna wrap it up in 1 minute. Crap. All right, I'm gonna come back to that in a minute. And thanks again, everyone, for following along on this, for hanging out with me for a couple of hours. A little bit less viewers than usual on a live stream, maybe because it's a Friday afternoon. But in just a few seconds here, I'm going to call this a day, and I'll push it up to GitHub for anyone who cares to keep looking at these things and playing with them. I feel like it's starting to get better, the I2C aspects of things. Yeah, okay, I mean, it worked. I mean, it does seem that it's reading out the date and time correctly. So I have a high confidence that I'm actually pushing this into a chrono object correctly. But I don't know. Maybe I need to do this get current time and be able to push back into it. But the block read and the block write definitely did not seem to be working correctly. So anyhow, thanks. And catch you all later.